Continuing on with our 13.1 lesson, now that we know the basics of our trigonometric functions, we want to be able to use them to solve triangles, more specifically right triangles. So in this case, now that we know the properties, or we know the values of all of our 60-degree angles, we know the sine, cosine, and tangent, we know that the sine of 60 is going to be the opposite over hypotenuse, remember. And we know that it's square root of 3 over 2. And in this specific case, our opposite is x, and our hypotenuse is 12. So we'd say x over 12. So if we want to find the missing length x, we just look at this final piece here, where we have root 3 over 2 equals x over 12. We just cross multiply and divide those, so cross multiply these. We have 12 root 3 equals 2x. Divide by 2 on both sides, and we are left with x equals 6 roots of 3, which, if you plug that into your calculator, should come to approximately 10.4. So this length over here is about 10.4. Thank goodness for trigonometry. Solving a right triangle. So in this case, all we are given is one angle and one side. And I guess technically we're also given this angle, the right angle, but we're always given that in a right triangle situation. Because we have a right triangle, and every triangle has to add up to 180 degrees, we can subtract the other two values, that 90 and 28, to find the value of our last angle over here, and that's going to come out to 62. So we'd say that this is 62 degrees right here. So now we know every single angle, but we still need to find the other two sides. So if we want to use just this 28 value, we are given its adjacent side, and we need to find its opposite side. So if we have a if we know an angle and we have the adjacent and we need the opposite, looks like we'd be looking at tangent. Remember TOA, so-called TOA. So we would say then that the tangent of 28 equals the opposite, so that YZ length that we don't know, over the adjacent, which is 11. So if we want to get YZ all on its own, we'd multiply both sides by 11, which would give us 11 times tangent 28. Remember this piece, tangent 28, that's one value all on its own. Then the 11 is separate. It's 11 times tangent of 28. So you have to keep those separate. So 11 times tangent of 28 equals YZ. And if we plug that into our calculators, that'll come out to approximately 5.8. So we'd say this is, again, we'll do kind of that squiggly equal sign, the approximately 5.8. If we want to look at our last value then, that hypotenuse, we want the h value right here. And again, we know that we're using 28 and are given 11. We could use the 5.8 if we want, but let's use the 11 because it's a little more exact. So in this case, we would say that the cosine of 28, cosine because we need adjacent and hypotenuse, cosine of 28 equals 11, the adjacent, over the hypotenuse, which is our yx. So in this case, to get yx alone, we can multiply yx by both sides. So yx times cosine 28 equals 11, and then divide by the cosine 28. So we'd be left with yx equals 11 over cosine 28. Now again, if we plug that into our calculators, that would give us approximately 12.5. So this value is 12.5. And then whatever units they are, maybe they're inches, feet, miles, whatever it is, but we now know what the value of each length is, or of each leg, and our missing angle. In this case, we are given only one of the angles, that right angle, but we're given all three sides. And we need to find the value of our two missing angles. So, if we wanted to look at A, we could say that the sine of A is the opposite, and if we're looking from A, the opposite is over here, hypotenuse, adjacent. So we'd have our opposite over hypotenuse. Now to get A alone, there's a function or a button on your calculator called the arc sine, or else on some calculators it might look like sine and have a little inverse there. So we would use this, the arc sine of 9/17 to equal A. And when we do that, we find the arc sine of 9/17. That means that A is approximately, we want to round, round to the nearest whole degree, so we'd say A is approximately 32 degrees. Now we could either just say, okay, 180 minus 90 minus 32 would give us our B value, but let's say we wanted to use trigonometry to find our B value. So we would say then, let's use sine again. We'll do sine of B equals, in this case, for B, these are going to be flipped. B's opposite is over here, and B's adjacent is over here. So the sine of B would be 14.4, the opposite over hypotenuse, which is 17. So same thing, we would do the arc sine of 14.4 over 17 equals B. And so B is going to be approximately 58 degrees, which fits because 58, 32, and 90 all add up to 180 degrees. So we would have our full triangle. Looking at the angle of elevation and depression. As you can see with our little friend down here, we have an observer and an object that he is looking at. Now when we have a horizontal line that goes right corresponding with the observer, the horizontal line and the sight of the observer create what is known as the angle of elevation. And you can remember that because you think that from him up to the airplane there is an elevation. It's elevating. Now from the object looking down, we call that the angle of depression. And again, you can remember that because depressing something is pushing it downwards. So from the object looking down, that's where the observer is. We can use these different angles, the angle of elevation, the angle of depression, in other real-life situations, such as the aerial run in Snowbird, Utah, has an angle of elevation, so starting from the bottom and looking upwards, of 20.2 degrees. Its vertical drop is 2,900 feet. Estimate the length of this run. So again, our angle of elevation here is 20.2 degrees, and we drop down 2,900 feet. As usual, we have our right angle given. So if we wanted to, we could just say 180 minus 90 minus 20.2 would give us 69.8 degrees, which would be this piece here. Oops, 69.8 degrees. But we don't necessarily need that part. It's nice to know so we can solve the rest of our triangle, but we didn't need that. All we're looking for is this length here. So again, if we know our angle here is 20.2 degrees, and we know that's opposite side and we're looking for the hypotenuse, we'd want to say that the sine of 20.2 is the opposite, 2,900, over hypotenuse, which is that length value. Now again, solving for length, we would multiply L onto both sides and divide the sine 20.2 from both sides. So we'd be left with L equals 2,900 over sine of 20.2. Which in the end, if you plug that into your calculator, that should come out to approximately 8,398.5. In this case, we're specifically looking at feet. So that's quite a long hill. Should be pretty fun. So again, we looked at all of our trigonometric functions today. If there are any questions, be sure you're asking in class. Otherwise, stay golden.